All right, so what we're going to do is we're going to take f of x and we're going to verify that both g of x and h of x are inverses of f of x. But the problem is that they're only inverses to certain sections of this. So just to do that, just to verify, the easiest way is to go ahead and type in the y equals to x. Okay? And you can see it's actually obvious that one side reflects over the other side of that line, y equals x. But then also we can take the composition, and if you remember that from the previous video, that means we take this and we stick it into that equation. And it's really easy. We just type f of g of x. What you should see is it overlaps that line. And then we can do the other one where we take f of h of x, and it should also overlap that. Okay, and it does, it changes that line just a little bit. So we verified that they are inverses at this point. Now what we're going to do is we're going to do what we call restricting the domain, okay? And the reason why we have to restrict the domain is simple, okay? We have to restrict the domain because the combination of these graphs right there, g of x, right, and f of x, or I'm sorry, h of x, they're two different functions, and they're not one individual function. And the reason why they're not an individual function is because if we do the vertical line test, meaning for every x value, there are two y values. Well, that means they can't be a function. So we have to split them up, and that is why we have the first equation and the second equation, so we can write an inverse function correctly. So what we're going to do to restrict the domain is first what we're going to do is I'm going to turn off some of these equations. I'm going to turn this one off, turn this one, and this one off, okay? And what you're going to notice is only part of the parabola is showing. The g of x part is actually showing right now, okay? And since g of x is showing, what I'm going to do is I'm going to come up to the top and I am going to restrict the domain so that only the reflection piece on the red graph that lines up with the green graph will show. And how we do that is simple. We find the vertex. So I'm going to find the vertex, which is right here, which is at -3, 4. X equals -3. And I'm going to write it all off of this value of -3. So I come up here to the top and I say absolute value of x is less than or equal to -3. Now check out what happens. Okay. Does that look like a reflection? Not really. It really doesn't anymore. Okay. It doesn't even line up anymore. So what I'm going to do is I'm going to come up here again and I'm going to switch it. That's all I have to do is greater than or equal to. And now check it out. Okay. You can tell that it is a reflection. And when I come over to this composition down here, the f of g of x, notice what happens. It shows up again. So whenever I restrict the domain, what I'm doing is I'm creating the inverse, and then I'm finding the interval for which they are matching up. So g of x and f of x line up only if x is greater than -3. But I can also change that now. So let's go ahead and change that one out again. I'm going to turn this one off now. And I'm going to turn on h of x. Okay. So when I turn on h of x, once again, you can tell that they are not inverses of each other because they are not reflecting over the x-axis. So I come back, I say, okay, well, I know x is -3. And that is the line of symmetry right there, x equals -3. And then what I'm going to do is I'm going to come back up here to f of x, and I'm going to change it. I'm going to say, okay, well, let's see if I can do this. I'm going to change the inequality to be less than or equal to. Now check it out. They line up, they're reflections, and I can check that composition right there. Let's see here. Okay, I can check that composition and check it out. They are reflections perfectly because the composition is lining up on y equals to x. And just as a reminder, this is where we write the restricted domain on the original function.